Hello, welcome back to Better Math. Now we're going to talk about angles and how we're going to use this. There's going to be 6 steps to this. I'm going to show how to find angles on parallelograms and on different shapes. So let's start with the first basic rules of shapes for geometry. So the first rule is when you have just a straight line. A line is just a straight across, basic, but the angle, let's say this was 2 arms and they were held out. So I'll hold my markers that way. They're held out like this. Well, this is the angle between them. So the way we mark an angle is like this with theta. So we have different types of angles. This is an angle that we call acute. And this angle is obtuse. We also have a right angle that's denoted by a square. And basically what these things mean is that this angle, the angle is less than 90 degrees. Obtuse is when the angle is greater than 90 degrees, and a right angle is when theta is equal to 90 degrees. Theta just means the angle. So yeah, the first thing that we're talking about is, with all these things in mind, we've got these 2 arms that are flat. And when the arms are flat, we know that it's always equal to 180 degrees. So here theta is equal to 180 degrees. That's useful for when we have a line intersected by another line. So let's say we know this angle is 45 degrees, and we want to find what theta is here. Well, all we have to know is that the whole angle is 180 degrees. So if the whole angle is 180, if we subtract off 45 for how many were in there, we're left with theta, because that's all that's left in the half circle. So we subtract this, we get 135 equals theta. So that's a way we can solve in that sort of situation. So that's the first example, and then we'll talk about another shape that is also easy to recognize, and that is just the triangle. So the triangle can be any shape, it doesn't matter, but if we have angle A, B, and C, we know that A plus B plus C must equal 180 degrees. This is very useful for when you have a couple angles. So let's say we know that this is a 45 degree angle, and this is a 45 degree angle. So if that's a 45 degree and that's a 45 degree, we know that this must be 90, because we rearrange this, 180 minus 45 must equal 90 degrees, which tells us that this is a right angle. And then we know that it is a isosceles triangle, because these sides are the same. So that's the first 2 parts. The next one we'll talk about is well, let's do an example on this. So let's say we have a triangle like this, such as this, and we know this angle is, not 40, it has to be higher. Let's say this angle is 100, and this angle is 80 degrees. We know this is our, let's say we don't know what this is, right? We don't know it's a right angle. I'll change it a little bit. So let's say this going to there. So this is, now it's smaller. So this is 20 degrees, let's say. So we have 100 degrees and 20 degrees, and we want to find out what is this angle theta. Well, we have to do both steps in combination here. We know that this whole angle is 180, so 180 minus the 100 that we already have is going to equal 80 degrees. So this angle in here is 80 degrees. Now if we have 80 degrees and 20 degrees, we know that the whole sums up to 180. So theta is going to be equal to 180 degrees for the whole triangle, minus the 80 we already have, minus the 20 we already have, which is going to be 80 degrees. So that is how you work with the first 2 steps with triangles and lines.